Hi, this is Mike Hendrickson from Velocity and Fluent in San Jose. I'm here with Tal from OverOps. Tal, how you doing?
Mike, good to meet you.
So, OverOps. For those out there that don't know what OverOps is, can you give us a high-level pitch of what it is?
For sure. OverOps tells companies when, where, and why their code breaks in production. We've helped more than 250 companies like Comcast, Fox, Kaiser Permanente, Zynga, dramatically reduce the time it takes them to detect and fix critical issues in production by an order of magnitude. We help their developers be more efficient. We help them deliver better, more stable and reliable applications and bring them to market much faster.
So if companies want to be on this whole CI/CD plan to continually integrate and continually deliver, they need you guys at the front in production, or before production they need it in dev and then all the way through production, or where are you guys most needed in an organization?
Both staging and production. Here's why. The whole notion behind CI/CD is get better software to the market faster, innovate more quickly, be at the cutting edge. In all companies today, they want to digitally transform themselves into these software powerhouses. But one of the biggest things that is preventing them from doing so is the fact that when you change things quickly, when you deploy things quickly, the chances of things breaking increase exponentially.
Right.
And this is where OverOps comes in. It gives you that security blanket that you know that if something does break in staging or production, you will be the first one to know. The right developer within your organization will be the right person, or will be the first person to know, and they will have all the information they will need. The source code, the variable state, debug level oxygen, JVM state, everything a developer will ever need to reproduce that issue, instead of having to spend days or weeks with that issue being undetected, having customers complain about it, churn, and a whole fire drill. Reducing that time from days and weeks down to hours and minutes. And that is something that truly enables and empowers CI and CD.
Okay, so I get the days and weeks down to minutes and the speed that we can deliver software now. But what about as systems become more complex? We're throwing in containers and microservices, and we're throwing in all this stuff, and we still want to deliver it on time and correct to our audience, so our market, our purchasers, our customers. So how, with the complexity, where does an engineering leader start?
That's so true. It's a three-dimensional problem. On one hand, you're expected to deliver more software, keep the highest levels of reliability and functionality, and scale it. It's a huge test that
and manage the complexity.
Exactly, the engineering leaders need to deal with. And the problem is all these applications in production, they emit tremendous amounts of data. Log files that look exactly the same, like if they were coming from an application that's 25 years old. Now, just flooding the system with petabytes, terabytes, gigabytes and gigabytes of data that's unstructured, complex to index and complex to analyze. And that's really when OverOps can help. Because instead of trying to index these massive amounts of log files, OverOps actually indexes the code, the DNA of the application. Even if that application becomes more complex, distributed, containerized, OverOps enables you to really make sense out of it. So when it breaks, it can tell you it's this location, it's this code, it's this variable, it's this container. This is what caused it. So it becomes proactive. Applications become smarter and more proactive, again, to use that word, in telling you where, when, and why they broke, versus you having to take data from thousands of containers, log data, and have your developers sift, regex, and parse through that manually.
So you have some sort of predictive, like it broke here before, and we can tell that you're going to break again? Is there a predictive nature to this?
There is. See, the thing is, and that's, I kind of alluded to that. You think about it, OverOps is almost like, in healthcare now, we talk a lot about like biological medicine.
Preemptive medicine.
Exactly. It kind of analyzes your DNA, and as a result of that, is able to kind of optimize your body. We do the same thing. Code is the DNA of any application. We analyze. We completely understand when, where, why, and what applications are emitting, and we're able to optimize it, make sense of it in real time. We can tell you exactly, this is what's happening, this is what's breaking, this is why it's doing it, and here's all the information that you need to know. And this is how we're helping our customers become much more proactive.
So you can track all the dependencies and things like that, that if one breaks, all of them are going to break. So you're bringing insight to developers quickly. But how can developers continue to develop as quick as we need as reliable as we need and as complex as all their distributed systems are, how do they continue to accelerate that even more and more and more with the use of a tool like OverOps?
I think, generally speaking, it all goes to automation. The only way, because you're going to get 100 times more software, but in the reality that we live in, for a company to say you're going to 100x, the amount of engineers that you have, that's not realistic. Most companies can't even fill in their hiring backlog for engineers.
Exactly.
So automation. How can we automate the process of detecting when software breaks? How can we automate the process of capturing the state? How can we use technologies like chatbots, essentially, to automate, again, the process by which we communicate with developers, saying, here, this is what you need to know. Click this to see everything that you need in order to be able to reproduce an issue. And how do we automate the process of verification? And once that fix is actually released and shipped, it never happens again. And this is what OverOps does. It automates the process of detection, state capture, reproduction, routing, and verification of issues as they occur in staging and production in real time.
And is that the future of it almost sounds like, do software developers still need to be in the loop? I know they do for now, but is there a future where that we're fully automated?
I don't know about that. That's too far away for us to see, but I would like to see a future where developers focus their time on writing code versus troubleshooting and debugging it. I think that's a future we could all agree on, that it's something that we want.
So deploying and testing could be shortened.
For sure, and we're seeing that. We're seeing deployment and testing. Those areas have been revolutionized, over the last few years. And now we're taking that same level of kind of revolution into production environments where the stakes are much higher. When It's all in real time, it's all customer facing. If we can bring those kinds of tools that we see in those earlier phases of the development process and lead them all the way to production, OverOps, what makes it unique, it's its ability to operate and run in these environments at very marginal performance overhead. So we can run sub-1 CPU performance overhead in environments that have thousands of nodes and process millions, and our customers process tens of billions of requests every day. So we're able to bring that innovation that so far has been confined to dev and testing to now staging and full-blown production. And that enables companies to know they are secure and safe and delivering better software to the market faster.
So if we have this conversation next year, and what would you like to see OverOps doing? So 12 months from now, you and I sit down in San Jose. What are you going to tell me OverOps has achieved in that 12-month period?
So first of all, that's a date. And what we will do, and what we'll be talking about, is really three things. A is just, the first one is just like we'll be adding more coverage for programming languages. Languages like .NET that we're releasing this fall, languages like Node.js. So giving more access to more developers to our tools. That's the first one. The second one, the tool is just getting stronger and better every week, every month, and every quarter. Amazing features built around anomaly detection, around distributed workflows that really go to the crux of the issues that pain developers and engineering teams that are the cutting edge of technology. And beyond that, I think, and this is something I'm just going to tease at this point, and next year we'll be talking about, is taking even one step further and saying, you know what, if log data, to this day, the lifeblood of every mission-critical application in the world today, is 25 years later still plain text files that are unstructured and complex to index and complex to analyze and are something that you don't want to be spending half your day staring at, and unfortunately probably hundreds of thousands or millions of engineers worldwide do. What can we do to essentially optimize that data, transform the underlying fabric of log data to make it 10x more cost efficient, 100 times more intelligent, and 1,000 times faster? So I think that's one topic that we'll be talking about here next year.
Excellent. We look forward to that conversation.
Sounds good to me.
Tal.
All right, cheers.